Have you ever looked at a large set of numbers, perhaps data points from a machine learning model, and wondered how you could quickly grasp its most important characteristics? How do you distill a vast amount of information into a few meaningful insights? The mean and variance are absolutely fundamental distribution parameters because they provide immediate, critical insights into the central tendency and spread of your data, acting as the bedrock for understanding any dataset in machine learning. They are the two most common ways to summarize the shape and behavior of nearly any distribution you encounter. These two parameters are so powerful because they capture the first two moments of a probability distribution. The mean, representing the first moment, tells us about the central location or average value, giving us a sense of where the data tends to cluster. The variance, the second moment, quantifies the average squared deviation from that mean, revealing how much the individual data points typically vary or spread out from the center. Understanding these moments allows us to quickly characterize the basic form of the distribution, which is crucial for statistical modeling and inference. To effectively use mean and variance, you can start by calculating them for your datasets, often available through standard statistical libraries in programming languages. Once you have these values, you can compare them across different datasets or against theoretical expectations. For example, a low variance indicates that data points are tightly clustered around the mean, suggesting high consistency, while a high variance implies a wide spread, indicating more variability or uncertainty. This practical comparison can guide decisions on feature scaling, outlier detection, and model selection. A fascinating insight is how these parameters are crucial in defining common probability distributions, such as the Gaussian, also known as the normal distribution. The Gaussian distribution is entirely characterized by its mean and variance. Once you know these two values, you can precisely describe its entire shape. This property makes them indispensable for modeling real-world phenomena, constructing confidence intervals, and performing hypothesis tests, especially when dealing with data that naturally follows a bell curve shape, which is common in many machine learning applications due to the central limit theorem. This theorem states that the sum of many independent random variables will tend toward a normal distribution, regardless of their original distributions, making mean and variance universally relevant. Ultimately, the mean gives you a clear picture of the typical value you can expect from your data, while the variance tells you how reliable or consistent that typical value is, by indicating the data's overall dispersion. Together, these two simple yet profound numbers equip you with a foundational understanding of data behavior, allowing you to make more informed decisions about your machine learning models and interpret their outputs with greater confidence and accuracy.